Okay, welcome to part 2 of a lesson on equivalent trig ratios. So I'm going to backtrack a little bit and look at this diagram here with theta and then its complementary angle pi over 2 minus theta. So looking at this right triangle, I'm going to label it. And let's say this is A and then this is B. Maybe just I'm going to use lowercase letters. So A, B, and C. And so let's say we write sine, so we write a ratio for sine theta. So sine theta here would be opposite over hypotenuse, right? It's going to be B over C. Now, if we write a ratio for cosine of pi over 2 minus theta, right? That's adjacent over hypotenuse. So the adjacent side here is B, and the hypotenuse is C. So notice it's the same thing, right? It's the same thing as sine of theta. Cosine of pi over 2 minus theta is equivalent to sine theta. Now we can try, let's also try cosine of theta. So cosine of theta so it's going to be A over C, right? Adjacent over hypotenuse. And sine of pi over 2 minus theta is going to be, so opposite over hypotenuse, so that's going to be A over C as well. Okay, and so that allows us to make this conclusion that sine of theta equals cosine of pi over 2 minus theta, and that cosine of theta is equal to sine pi over 2 minus theta. Okay, so this is a visual representation of these cofunction identities. And the same would apply for tangent and cotangent, cosecant and secant. Okay, so going back to example 3. So here it says, given that cosine of pi over 7 is equal to sine of y, use a cofunction identity to determine sine y. Or angle y, sorry. Okay, so to determine angle y, okay, so what we can do here is, starting with cosine of pi over 7, we can write it as, we know that it's going to be sine of pi over 2 minus pi over 7. So using the cofunction identity here. And so then this is going to be sine of 7 pi over 14 minus 2 pi over 14. And so that's going to give us sine of 5 pi over 14. Okay, and so that is what y is going to be actually, right? So therefore, y is equal to 5 pi over 14. That's the angle in radians. So just using a cofunction identity. All right, so just to summarize this, we're gonna look at this now. So we're going to compare related angles to principal angles. So using the fact that the unit circle has coordinates cos theta, sine theta. So recall that if we have a point on the unit circle at the end of the terminal arm, the point here, since the hypotenuse or the length of the terminal arm is 1, any point can be written as just cosine theta multiplied by, or not multiplied, cosine theta, sine theta, right? So the x-coordinate of the point at the end of the terminal arm is cosine theta, and the y-coordinate of the point at the end of the terminal arm is sine theta. Now it's 1 times cosine theta and 1 times sine theta. I'm just not writing the 1, just because it's equivalent, right? Having a 1 in front or not having it, it's exactly the same. So recognizing that, what we want to do here is we want to explain why sine of pi minus theta is equal to sine theta, and then do the same thing for the other one. So cosine of pi minus theta is equal to negative cosine theta. So one thing about this is, so if we look at this point over here, this point here would be negative cosine theta and then positive sine theta, right? We know that cosine is negative in the second quadrant, and sine is still positive because, well, the y values are positive in the second quadrant while the x values are negative. So we have that. So what we can see from that actually is that sine of pi minus theta, which is being shown there in that diagram, would be just equivalent to just sine theta. We can see that here we have positive sine theta, and also here we have positive sine theta because sine is positive in the first quadrant and in the second, right? And so they're equivalent. We could say sine is positive in quadrant 2. Okay, and that's somewhat of a justification for this. Now cosine we can see is negative in quadrant 2. Because the x values are negative. So cosine, just going to write cos is negative in Q2. And then lastly, tangent. Now tangent we know is sine over cosine, right? Sine theta over cosine theta. And so since sine is positive while cosine is negative, right, this would just be negative, it would be negative sine theta over cosine theta. So I'll just write it actually like sine theta over negative cosine theta. And so that is going to be negative tangent theta. So tangent is also negative in the second quadrant along with cosine. Tan is negative in Q2. All right, let's now look at Q3. So we want to write similar statements for the following diagrams. So a sine statement, cosine statement, and a tangent statement. So we want to recognize so that this point over here at the end of the terminal arm is cosine theta. So 1 times cosine theta and sine theta. Now, this point over here at the end of the terminal arm in quadrant 3, so we first want to describe this angle. We want to describe what is this principal angle over here. So we're adding, right? We're taking pi and we are adding theta to it. Okay? That's what this angle is here. And so what we can write for this would be, so first for sine, right? So sine, so similar to these other ones that we wrote. So pi plus theta would equal, so in this quadrant, cosine is going to be negative because it's quadrant 3. Cosine is negative. Here the x values are negative. Now sine is also negative because the y values are negative. So that would mean that this is going to equal negative sine of theta. Now cosine is going to be fairly similar. So cosine pi plus theta is going to equal negative cosine theta because cosine is negative in the third quadrant. And then lastly, tangent pi plus theta is going to be positive tangent theta. And that's because tangent is positive in the third quadrant since both sine and cosine are negative. And tangent theta is equal to sine theta over cosine theta. Okay, now for this last diagram here. So this, in this case, the principal angle, this would be 2 pi minus theta. That's our principal angle. And so over here, cosine is positive, while sine would be negative. And so the statements that we could write here is we could write sine 2 pi minus theta would equal negative sine theta. And then our cosine statement would be cosine pi minus theta is equal to positive cosine theta. And then the tangent statement so tangent of 2 pi minus theta would equal negative, because tangent is negative in the fourth quadrant, negative tangent theta. Okay, and so this is a fairly good summary of comparing principal angles and related acute angles to each other. So these are all known as identities. So a variety of different identities in this lesson. So for homework, I would like you to complete this worksheet as a variety of different types of questions related to cofunction identities and some of the other identities that we have looked at. And apart from that, there are also some questions from the textbook. So refer to the unit outline, lesson 3, for the textbook questions. And that wraps up this lesson. Thank you for watching, and have a good rest of the day.